Not all web services are free, and in Mathematica you can access services that cost money for each transaction. And I'll say a little bit about those. We won't actually be using any of them, but I'll say a little bit about those before we jump into our first example. One way of using these services involves what are known as service credits. So you pay for a batch of credits and then you can spend them using various APIs. These APIs that cost money to use involve doing things like web search, web image search, translating texts, searching for geographical images, and sending messages out to smartphones and things like that. Now you can check to see how many service credits you have available if you'd like to experiment with this. And if you do design a project that makes use of service credits, you want to read this article first so that you know what you're getting in for. There's also a thing called Wolfram Cloud Credits, which allow you to put up your own web service or API. And again, you can check to see how many cloud credits you have available if you want to experiment with this. There's also a command called Cloud Account Data, which I've commented out, but you can use that to get more details about hosting your own APIs. As we've seen before, Mathematica has a sophisticated service framework that can be used to connect to particular sites. And for some of these services, you also need to have paid accounts. Some of them, you don't necessarily need paid accounts, but you have to do authentication, which means you usually have to be a member of the site and have signed up to interact with its API. That includes things like Facebook and Twitter and LinkedIn and Instagram, storage sites like Flickr and Dropbox, personal sites like your Google Calendar or Google Contacts, health sites, business search analytics. So there's tons of these, and I put a bunch of them in the project ideas section at the end of the book. In the lesson on citations, we use the service framework to access the Open Library API, which doesn't require service credits or authentication. Now what we're going to do now is we're going to look at the OCLC WorldCat identities. This is a very large database of named entities that includes links between the records. In this case, there's a summary page for every name in the OCLC WorldCat. So WorldCat confederates or brings together, aggregates the catalogs of many, many libraries around the world. They have an enormous aggregated library catalog that you can explore. And in that catalog, there are about 30 million entities, and these include things like persons, organizations, and fictional characters. We can get at these pages by going to worldcat.org to the Identities section. So what we're going to do here is we're going to grab a single entity, a single person from this massive database of identities, and then we're going to use crawling techniques or spidering techniques to find the network around that person and then to find the network around each of the people that link to that person. So we're going to start with this fellow, Walter Lippmann. And we start by setting a base URL, and we use his Library of Congress ID number. This is a unique identifier that refers specifically to Lippmann. And then we can just use import. We join the base URL to his unique identifier and ask for elements, and it shows us all of the information that we can get about him. Now I'm just going to pop this open in a browser so you can see what this looks like in a browser. We're not going to be accessing it in a browser specifically, but there's what it looks like if we were to access his identity in the WorldCat Identities database through the browser. Okay, so this is the information about Lippmann. Now we have a function here which, when we give it an ID, returns names and associated IDs. And what it's retrieving, let me just go over to this web page, is if I scroll down the Lippmann page, down at the bottom here you see there's this list of linked identities, and these related identities link Lippmann to other people, other institutions, and so on. So we can use this function we just defined with Lippmann's unique identifier and pull out Ronald Steele, the Oliver Wendell Holmes collection at the Library of Congress. And if we look at the web page, we see that this is what we're retrieving here, these related identities. If we choose one of them, I just chose the Council on Foreign Relations, I can get the identities that are linked to that entity. So Lippmann links to the Council on Foreign Relations. If I click through to the Council on Foreign Relations and I scroll down to the bottom, under its related identities we have the Center for Preventative Action, as you can see. So let's bundle this process up into a function that will do this kind of automatically. What I'm going to do is I want to get what I'm going to call a neighborhood. I'm going to get all the identities around Lippmann, and I can use the short command just to show what that looks like. So Lippmann points to Ronald Steele, Lippmann points to the Oliver Wendell Holmes collection. Now we can use a graph to show this network that we've plotted. So we've basically taken two hops. We've started with Lippmann, we've jumped to the related identities that surround Lippmann, and then for each of those we jump to the related identities. And when I evaluate this, I end up with a network. Now this, I just want to zoom out here for a moment. I saved a copy of this graph so we can see what it looks like in the... So if we zoom way out, we can see that there's Lippmann here in the center, and then there's the identities around him, and in each of those I have identities around that. If we zoom in, we can actually see who these various people are and how they're related to one another. And one of the things that we notice, for example, is that, and again I'll just draw your attention to the things where we're kind of more zoomed out, is that the entities don't just relate to Lippmann, they also tend to relate to one another. So some of these nodes will have other nodes in common that bridge those parts of the network. Now, as we've seen before, we can use find graph communities to visualize the communities around him. So here's a list of the various communities, and we can plot it with community graph plot. That looks like this. So each one of these clusters corresponds to one of these communities that's been identified. This one here, let's highlight that. If I roll over this, the mouse to point to the element, this thing called a tooltip shows me that this is the Council on Foreign Relations. If I go over here and look at this one, this is the University of Virginia Library Electronic Text Center.